Thank you very much. I'm MicheleTrenti from the University of Melbourne, and it is my great pleasure to present you today the SpIRIT mission. So, as the principal investigator of SpIRIT, I feel both a great honor and responsibility that our team has been competitively selected by the Australian Space Agency for its first mission, where there is a contribution for funding. So SpIRIT, which stands for Space Industry Responsive Intelligent Thermal CubeSat, is a 6U, about 12 kilo nanosatellites, which has substantial ambitions for its class, as reflected by the approximately $6 million budget up to construction and launch, so up to phase D, out of which about 4 million comes from the Australian Space Agency. So SpIRIT is an Australia-Italy mission with an Australia-made spacecraft, which will be the first made-in-Australia spacecraft to host an instrument payload provided by the International Space Agency, specifically by the Italian Space Agency, which has just delivered a gamma and X-ray instrument to the University of Melbourne for integration in the satellite. So the key goals of SpIRIT are to carry out monitoring of gamma ray bursts in the sky, thanks to the contribution of the Italian Space Agency. We're also developing technology here in Australia, in particular in the areas of thermal control, rapid communication, and through collaboration with industry partners, electric propulsions and platform technologies. So very important goal for us is also to grow collaborations between industry and academia, and in doing so to help achieve the goals of the Australian Space Agency to promote the growth in the Australian space sector. In this image, I have a schematic of the SpIRIT CAD with key elements highlighted. So SpIRIT is based on the Apogee nanosatellite platform being developed by our industry partner, Innovative Technologies. At the University of Melbourne, in addition to mission lead, we're developing 3 payloads for the spacecraft. The PMS, which stands for Payload Management System, is a module for managing all the payloads on board the spacecraft and also performing data analysis on the satellite, so edge computing. Another module that we developed in the University of Melbourne is the Mercury subsystem for low latency communications and for autonomous decisions in nanosatellite operations. Last, at the University of Melbourne, we are also developing a thermal management system called the Themis, which is based on a Stirling cycle cooler, which will actively lower and carry out precision temperature control for the Hermes instrument provided by the Italian Space Agency. SpIRIT will also host the Neumann thruster. It will be the first in-orbit demonstration of this novel Australian electric propulsion technology. And we have Nova Systems as our partner for ground segment. Just very briefly, the science case that underpins the Australia-Italy collaboration on SpIRIT is inherited from the Hermes instrument provided by the Italian Space Agency, which will allow us to study the transient universe at high energy. So we'll study gamma ray bursts and gravitational wave electromagnetic counterparts. We look, thanks to the high time resolution of the instrument, into the inner engine that powers this powerful cosmic explosion GRBs, and also possibly set some limits on the granular structure of the space-time. Just to summarize the idea behind having a CubeSat for science, thanks to the Hermes instrument and innovations such as active cooling on SpIRIT, we expect to achieve performances for the Hermes constellation, of which SpIRIT is one of the 7 elements, that will be on par to a complex instrument such as the Fermi Gamma Burst Monitor currently in space for just 1/10 of the cost, demonstrating how agile projects for CubeSats can deliver both for industry and for scientific research. Let me give you just a very brief hardware highlight. In this picture you can see our engineering model following electrical compatibility and mechanical environmental tests that we carried out a few months ago, with the Norman thruster here in front of the picture. If we zoom in on the left, we have here the Themis engineering model with deployed thermal radiators in this configuration, as it is sitting on the integration jig while performing some integration tests for the final assembly of the flight hardware. Currently, we have terminated successfully the fabrication of all flight elements, and we are ongoing assembly, integration, and testing. We received the Hermes instrument and successfully operated it through the University of Melbourne PMS last month. We expect to conduct integrated satellite tests starting from September. We have booked a seat on Falcon 9 Transporter 8 to a sun-synchronous polar orbit for April next year. We expect after commissioning to start about 20 months of operations in about a year time. And the next phase during operations will focus on learning lessons from operations in orbit and redesign the technology with the idea of going beyond CubeSats and aiming for deep space exploration. And learn more about SpIRIT on our website. Finally, let me just spend half a minute to highlight where SpIRIT is being designed and built. At the Melbourne Space Laboratory of the University of Melbourne, we are focusing on developing high-performance, innovative space instrumentation. The core areas we are active on are reflected by the SpIRIT mission: active thermal control, low power edge computing and artificial intelligence, and low latency communications. We have a couple of other projects in the pipeline beyond SpIRIT, and we would be looking forward to establishing new collaborations both with industry and with other academic institutions. So thank you very much.